Alright, so let's do this very quick problem. So we have find the vertical and horizontal asymptotes as well as the domain and range of the graph of f of x equals -3 over x plus 1 plus 2, right? Now, one of the things about this one is that it is not, so it is of this form, so just to kind of quickly go over, it's a over x minus h plus k. And so basically here, to find the vertical asymptotes, what we have to do actually, and let me try to actually see if I have this correct. So give me 1 second. All right, so no matter what number we are adding by, this part here is really still your vertical asymptote. So it doesn't really matter how it is. But your horizontal asymptote, I believe it's different. So just to be safe, we're going to go ahead and for the vertical asymptote, yes, it's going to be, you're going to set x plus 1 equal to 0, and you're going to go ahead and subtract 1 on both sides, right? And doing so, you get x equals -1, right? And that is, that is your vertical asymptote. Now, for your horizontal asymptote, you can go ahead and add both of these just to be safe, because the thing is that anytime it's of the form ax plus b over cx plus d, it really depends, or ax to the n over cx to the m, right? It really depends on what your powers are. So that's kind of why I want to go ahead and, and add both of these. So we're going to go ahead and add them. Now, we can use this rule, a over b plus or minus c over d equals ad plus or minus bc over bd. Now, we're going to say that we're going to do this. It basically is cross multiplication. -3 plus 2 times x plus 1 all over x plus 1, right? And so then we have -3 plus, we're going to distribute 2x plus 2 over x plus 1, right? So then we have -3 plus 2 plus 2x over x plus 1. This gives us 2x minus 1 over x plus 1. And now we see that basically the horizontal asymptote, we have, they both have the same degree. They have the degree of 1. So that means that the horizontal asymptote is really just 2x over x, or 2, but it's y equals 2, right? So the horizontal asymptote is y equals 2, right? Now it wants us to find the domain and range. So here's the thing: if you think about it, you can go ahead and try to sketch this as best as you can, but we have, I'm sorry guys, it's raining outside. We have a vertical asymptote at x equals -1, excuse me. So give me 1 second. And if you look at the sketch of the graph of -1 over x, you know that as x goes to infinity, so anytime x gets larger and larger, we are basically, so it goes -1 over 1, which is like this, -1 over 2, which is like this, and it just keeps going like this, right? Now what about as x approaches -infinity? So as x approaches -infinity, it goes like this, and it goes basically it rises from the left hand side, right? So we know that this graph is going to have this kind of shape. It's going to look something like this, right? Where, you know, it's kind of, that's kind of a rough sketch, but it'll look something along the lines of this. And so basically we know that for the domain of the function, the graph, so obviously the vertical asymptote is x equals -1. This is the vertical asymptote here, right? Now it's gonna go up from the left, and the horizontal asymptote we said was y equals 2. So the horizontal asymptote is going to be about right here. This is y equals 2. Right, and maybe I can color code this very quickly. So the horizontal asymptote we said was y equals 2, so it'll be kind of like right here. So this will be the horizontal asymptote at y equals 2, and then we go ahead and put the vertical asymptote right here at x equals -1. So basically this is the vertical asymptote x equals -1, which is exactly what we put before. But yeah. Right. So this is our vertical asymptote, x equals -1, and that's our horizontal asymptote, y equals 2. So now we're just kind of sketching, or we're kind of making a little rough sketch of how this looks. So basically it'll look something like this. And again, we're not graphing it, we're just sketching it. We're just sketching it so that we can know, okay, like where does it, you know, how is the end behavior looking, right? Now, to find the domain and range, the domain, as you can see, goes from -infinity, and then over here is infinity. But look at right here, it doesn't touch x equals -1. So basically the domain is all real numbers such that x does not equal -1. Now, the range is going to be all real numbers such that y does not equal 2. So what does that mean in interval notation? That means that in interval notation, our domain and range are going to be, so that for the domain we're going to have, it's going to be from -infinity to -1 with a parentheses because we're not including -1, and then union -1 to infinity, right? For our range, we're going to have, so for our range, we are going to have from infinity to 2, union, and then again, we're not including 2, so we're just going to put parentheses 2 to infinity. And that's the domain and range of this function. And the vertical asymptote and horizontal asymptote. So the vertical asymptote we said was x equals -1. And the horizontal asymptote we said was y equals -2. Or did we say, I'm sorry, y equals 2. Excuse me. So this is how you actually find the vertical and horizontal asymptotes as well as the domain and range of this function here, okay? So I hope that helps, guys. I know it was a little bit, it was a little bit of a, kind of a long video, but not too bad. If you have any questions, please let me know. Please like, comment, and or subscribe, and I will see you guys in the next video. Thank you so much for watching, guys, and I will see you guys next time. Bye, guys.